Wheatstone bridge, the name of a scientist, Wheatstone. He proposed an idea that if there are 4 resistances along each side of a quadrilateral, this would be given the term Wheatstone bridge. You see, this was introduced in 1843, and since its inception, so far it could never be challenged. Its utility remains where it was in the earlier days. It is at the very same place even now also. 4 resistances P, Q, R, S have been given. This A, B, C, you see the 4 resistances P, Q, R and S, A, B, C and D. In all the books, you see, this is the only figure I have explored throughout my teaching career, that in this bridge most of the authors follow the same pattern. They give the name A, B, C, D, and along one diagonal there is one galvanometer along with key. With this diagonal there is one cell along with the key. The current passes through here. It will be divided in 2 parts. You see, when the bridge is balanced, in that case the galvanometer will show null deflection, and that confirms that in that case potential of B and D both are equal. This is possible only when P upon Q is equal to R upon S. You see, when the bridge is not balanced, obviously the galvanometer will be giving some deflection and current will pass through this also. One thing is very important: when the bridge is balanced, you can interchange the galvanometer and the cell. Means AC and BD, both the sides are interchangeable, going to make no impact on the balance of the bridge. That is why these are also called conjugate arms, AC and BD. These 2 arms P and Q are called known ratio arms, and known resistance is connected across this side. That is why it is known R. Resistance that we want to calculate, unknown resistance, that is connected along S. If you want to find out the potential difference between these 2 points when the bridge is not balanced, you have to remember one relation. In the denominator you are going to have P plus Q, R plus S, and here it is E multiplied by, within bracket you will write Q R minus P S, VB minus VD. One more thing you must remember: if P upon Q, this is less than R upon S, you see, in that case potential of B is going to be greater than potential of D. It is quite inverse. You see, P upon Q is less, then you find VB is greater than VD. This principle of bridge is used to find the unknown resistances, meter bridge, post office box. These are based on the same principle. It is very important. The principle of bridge is very important in calibration of measuring instrument. And finally, one more thing: if you consider all the resistances of the same order or of same magnitude, in that case you see the bridge is going to be the most sensitive.